Today, we talk about this title De-rendering Stylized Texts from Cyber Agent and Kyushu University in Japan. We introduce the motivation of this work. Designers make designs with the user interface for designs such as Photoshop or Illustrator or PowerPoint in general. Designers edit an image with vector graphic format in such UI. In the vector graphic format, each asset is separated into some visible layers, and some assets such as text, geometrical figures can be further decomposed into rendering parameters. Designers can flexibly edit the image with the vector format, but the vector images tend to be large capacity. To compress, we can export vector images to raster image format, while we cannot inverse raster images to vector images in general. Our research objective is to vectorize texts in a raster image using a neural net. Though the raster image cannot convert to vector image as we explained before, we achieve this by utilizing neural net. To convert raster text images to vector format, we propose to estimate rendering parameters from a raster text image for vectorization of the texts. Our approach is equivalent to viewing text recognition as a de-rendering problem, where the goal is to predict rendering parameters. If the texts can be represented in the sets of the rendering engine parameters, we can flexibly edit texts by editing numerical values in rendering parameters. This figure shows the overview of the proposed model. The proposed model consists of feedforward parser and feedback refiner. Our model passes text information by detector, in Painter, and multiple style estimator. Note that the predicted rendering parameters can be exported to external rendering engine. To alleviate the inconsistent visual appearance due to the independent multiple task prediction, we refine the parameters by feedback inference. Our feedback refiner reconstructs texts from the predicted parameters through alpha generator, warper, and compositor. Our feedback refinement incorporates differentiable rendering to reproduce the given raster text and fit the parameters to the raster input using reconstruction loss. This slide shows the example of the feedback refinement. Our refinement process starts from the rough initialization by feedforward parser, and gradually fits the parameters to reproduce the given raster image. Note, our differentiable reconstruction is only for refinement purpose. This slide shows the demonstration of the proposed text editing. The proposed model predict and refine the rendering parameters in 2 steps. We can export the rendering parameters to an external rendering engine as a vector graphic image. We can edit the texts by editing the rendering parameters with only off-the-shelf processing. Note that the proposed model is trained with rendering parameters whose format is frequently used in the web and various rendering user interfaces. We compare the quality of our editing approach with a state-of-the-art raster editing method SRNet. We observe that SRNet often fails to draw a straight line and prone to be small artifacts, while our approach completely separates text shape from text effects in the parametric representation and does not suffer from artifacts. In this slide, we show some results of the reconstructed text images. From left to the right, we show in input images, initial reconstructions, refined reconstructions, and final vectorization results using a 2D graphic engine. We observe that our approach successfully passes text information including detailed style information such as the weight of borderline and shadow orientation. The proposed model can use the text style of another text on the rendering step. Here, we show more detailed examples of text style transfer. 5 different styles are transferred to a text in an input image. Note again that the proposed model can transfer not just font style but also effect style. Summary: we formulate raster text editing as a de-rendering problem. We propose a vectorization model to pass detailed text information, using forward and backward inference procedure that takes advantage of differentiable rendering. We empirically show that our model achieves high-quality parsing of rendering parameters. We also demonstrate that the parsed information can be successfully utilized in a 2D graphics engine for downstream edit tasks. One limitation of our approach is that effects must be pre-defined by the rendering engine. For future work, we wish to expand the available effects and blending operations in the future.